So if you guys have a problem that's like in this notation, there's two different ways you guys can do this. You can solve it from this way. Raise your hand if you know what I'm talking about from that. Like solve it how it is without rewriting it. OK, half the class. So I'll show you how to do that at the end. I'll just show you guys the long way first, so those of you guys can do it. And then I won't show it like that again. But basically, ladies and gentlemen, when you have an inequality like this, the best ways to make sense of it, especially if it gets confusing, is just to cover up one inequality and the quantity that it's equal to, and just write down what you have remaining. So therefore, I'd have -5 is less than or equal to 2x plus 1. And this produces an and inequality, by the way. And then cover up the other side, which would be 2x plus 1 is less than or equal to 9. So basically, all this is this is just two inequalities put together. OK? So if you want to separate them out, just understand by separating them, it produces an and inequality. Which, remember, an and inequality, they both have to be true, right? So now we're going to go ahead and solve these separately. So you're going to solve for x, so you subtract 1. So I have -6 is less than or equal to 2x. Divide by 2, divide by 2. -3 is less than or equal to x. Now, I do not like solving an inequality when my variable is on the right-hand side. Sometimes I make mistakes. So I'm going to rewrite this with the variable on the left-hand side. So I'm just going to flip everything, including my sign. So therefore, this becomes x is greater than or equal to -3. Just verify it's the exact same answer, just now the x is on the other side. Over here, I'll go ahead and solve for x. OK, so now we have two inequalities. There's a couple different ways I like to do this. I think one of the easiest ways you guys can do this is, again, an and is you can graph them on the same graph. Just remember, we're looking for the intersection, right? And you and your parent have to show up to open house. It only works when both of them are true. So we're going to make sure we include both of these. So I had 0, 1, 2, 3, 4, 5, 6, -1, -2, -3, -4, -5. OK, so yes?
For the -3 is less than x, isn't that both of them the same when you flip this sign?
Oh, when you're solving? I didn't do any examples like this. I'll make sure I do that for inequalities. But remember, that's only when you have to multiply or divide by a negative on both sides. So here, to solve, all I did to solve was subtract a 1. So I didn't multiply or divide by a negative number. Here, I had to divide by a +2. So I didn't have to multiply by a negative number. However, if I had to multiply like by a -2, then I would have had to flip the sign. OK? So we go ahead and graph x is greater than or equal to -3. So I make a nice point, solution point at -3. Remember, that point is greater than or equal to, so it's a part of the solution. Then what I'm going to do is, rather than graphing on the line, I'm going to graph above the line. And I'm going to say all the points above the line go this way. Then I go to x is less than or equal to 4. That's another closed point. But that's going to be all the values that are less than, which is going to go to the left. OK? So now what you guys can do, again, what we're looking for, since it's an and, we're looking for the intersection. Where is it true for both of them? And that's going to be the value, the area, in between your two solution points. Make sense? Any questions? And you're looking for the intersection.